And today HCl chemistry. Welcome to HCl chemistry. And today chapter started on in the solid chapter. How is the solid is formation? How is the solid is construction? Depends upon of the constituent particles internally, and inside of the constituent particles is the depends upon in the formation of the solid. And first is observed that in the this one is the solid is how it is for formation is the constituent particles, and this is the constituent particles and in a fixed position. Constituent particles in a fixed positions. The constituent particles in a fixed position is come. Okay, and this is what you call, and what you call that in the constituent. What you understood that in the constituent, two or more particles, two or more is combined together, two or more is combined together, and two or more is combined together is called that in the constituent. Two or more is combined together is called that in the constituent. This one is called that. And this one is the constituent particles are in a fixed position. This one is called that in the constituent particles in a fixed positions. And another one, and this one solid is formation. And it is like to be another name is what you call rigidity. And the rigidity is what do you call that in the rigidity? And rigidity is called that in the interparticles interactions. Interparticles interaction is called that in the rigidity. And interparticles is what? Interparticles is called that in the bonds between the atoms and molecules. Bonds between the atoms and molecules is called that in the interparticles interactions. First, how is the solid is formation? The solid is formation and construction is come to that in the depends upon of the constituent particles in a fixed positions. Then, and this is what you call solid is called that in the rigidity. And what do you call that in the rigidity? Interparticle and interaction is called that in the rigidity. And this one is observed that how is the solid is depends upon the constituent particles. And then I give to that one example, this one, and you already know about it. And this is the solid. The constituent particles is the fixed positions. The constituent particles at the fixed position. This is what you call solid. The solid is converted into the liquid. Solid is converted into the liquid. The particles is the loosely arrangement, loosely particles. This is what you call liquid. And again, this one is come to that with the gaseous. The gaseous particles. This one is called that in the gaseous particles. First is solid is converted into the liquid, liquid is converted into the gaseous, depends upon the temperature. For example, this is the solid H2O, and ice H2O. Okay, solid H2O, and I give that in the temperature is the 25 degrees Celsius, and solid is converted into the liquid. And how it is the liquid is converted? This is the arrangement of the particles is the loosely arrangement. Therefore, is converted into the liquid. Again, is the liquid is converted into the gaseous particles. I give that in the 200 degrees Celsius temperature. What happened this one? And particles is a very loosely arrangement of the particle. Therefore, is converted in the this is converted in the gaseous particles. This is the closed beaker. Again. And this is the closed beaker, and again is converted to the this one, and temperature is changes, and I give that in the 10 degrees Celsius, and again is converted to the liquid, and liquid is again is converted, and temperature is due to that in the -2 degrees Celsius. Liquid is converted to the solid. Therefore, and depends upon what happened this one depends upon is the constituent particles is the closely arrangement and very tightly particles is formation, that is called that in the solid. Therefore, if you have observed that here, solid is come and the closely arrangement of the particles, this one, liquid is the loosely arrangement of the particle. The gaseous is the very loosely arrangement of the particle. Another name is what you call, this is the interparticle, this is the rigidity. And this one is one name is called that in the oscillating about there in the mean positions. Oscillating about there in the mean position. What I understood that in the oscillating about there in the mean positions means what? Oscillating means what? Oscillating about there in the mean positions means oscillating means is like to be the bar pendulum. The particles is observed that is very closely, and then after that loosely, again is very loosely. Temperature changes, again is the small loosely, again is completed in the solid and very tightly arrangement. Therefore, is completed in the simply say that in the inside of the particles is like to be elastical properties. If you come to that in the again is the original positions. If you observe that in your hand, when it is the if you dragging, and if you are come to that in the this one oscillating about there in the mean position is come to that when is the elastical properties is stretching, again come to that in the mean position, again come to that in the original position, that is called that in the oscillating about their mean position. If you observe that here, first is come to that in the particles is the very randomly move, again is the very randomly move, and temperature changes. What happened that one, this one is the very closely arrangement of the particles. This one is what you call oscillating about there in the mean position is called that. Understood? And solid is converted into liquid is converted into gaseous. Depends upon of the inside of the particles. Very tightly arrangement of the particles is come to that in the solid. Very loosely, and it is called that in the liquid. Very loosely arrangement is called that in the gaseous form. Again come to that in the original position. That one is called that in the what you call oscillating about there in the mean positions. This is understood how is the solid is occurrence, how is the solid is produced, how is the solid construction. Depends upon of the inside of the constituent particles. That one is the solid is formation. You already know, and solid is the fixed position. It is like to be a rigidity. It is solid is the inside of the particle is the fixed position, and it is like to be a rigidity. Then if you go to that in the characteristic of solid, characteristic of the solid is how it is. You already know characteristic of the solid, and characteristic of the solid is come to that in the it is definite shape, definite volume, and definite volume, and it is identity. That one you already know, okay? And you already know about it. This is the closely arrangement of the particles is like to be is the definite shape, and this one is the definite volume and high density. This is the characteristic of solid. Then after that characteristic of the solid you already know, and then if you go to that in the solid is again is classification. Solid is again classification is the crystalline solid. And this one is what you call amorphous solid. Crystalline solid is called an amorphous solid. Crystalline solid is completed in the orderly arrangement, geometrical shape, This one orderly arrangement. The particles is a orderly arrangement. It's a geometrical shape. This is the true solid. What are you understood that is the true solid? True solid is the symmetrically arrangement of the particles, and the symmetrical arrangement of the particles is called that in the symmetrical arrangement of the particles is called that in the true solid. First is observe that crystalline solid is come to that in the orderly arrangement. Then after that geometrical shape, and it is what you call true solid. Why it is the true solid is called, and this is the symmetrical arrangement of the particles is called that in the true solid. What is the symmetrical? Symmetrical means cut into the equal pieces. When it is cut, equal piece is produced. That is called that in the symmetrical. What do you call that in the symmetrical? Cut into the equal piece is produced is called that in the symmetrical. That one. And then after that, this is another name, and this is the crystalline solid is the fixed temperature, and sharp melting point. Fixed temperature and sharp melting point means fixed temperature. Why this is called in the fixed temperature? You already know the crystalline solid is particles is the orderly arrangement. Crystalline solid is the particles is the orderly arrangement. This is called that is the orderly arrangement. And when it is that in the fixed temperature is produced. Why? When it is due to the temperature is the no randomly arrangement, therefore it is the orderly arrangement. When due to that particular temperature is the and easily melting, sharp melting point. Therefore, and this one is the fixed temperature. And another one, and this is what you call anaesthropic nature. Anaesthropic nature. What do you call that in the anaesthropic nature? Anaesthropic nature means anaesthropic nature and different arrangement of the particles, different arrangement of the particles, different arrangement of the particles, different directions, different arrangement of the particles, different directions, different arrangement of the particles and different directions. This is what you call anaesthropic nature. What do you call that in the anaesthropic nature? Crystalline solid is called that. Anaesthropic nature means why? Different arrangement of the particles and different direction. I give you that one example. And for example is the Na plus and Cl minus, Na plus and Cl minus, Cl minus Na plus and Cl minus Na plus, and then after that Na plus and Cl minus, Na plus and Cl minus. Observe that this one leaves, and what happened that and different arrangement of the particle. First leaves is observe this one Cl minus, Na plus and Cl minus. Again this side is observe that, this side is observe that, and Na plus and Na plus and Na plus. Therefore this is called that in the anaesthropic nature. Why? Different arrangement of the particles. Na plus Cl minus is the different arrangement of the particles. Na plus and Cl minus, Cl plus Na plus, different arrangement of the particle and different direction is occurring. First we observe that here Na plus is come. First we and second we is observe that Cl minus and Na plus and Cl minus. Therefore, this one anaesthropic nature, why it is called that in the different arrangement of the particles and different direction is occurrence. Therefore, that one is called that in the anaesthropic nature. If you have that one, we observe that in the different direction is occurrence. Another view is observed that in the different direction is occurrence. Therefore, that one is called that in the anaesthropic nature. Crystalline solid is anaesthropic nature. Why? If you have called that different arrangement of the particles along the different direction is formation. Then this is you already know crystalline solid is and short range order and long range order. This is the short range and as well as is the long range order. Short range and long range order. This is the short range and long range order is depends upon the nature of the particles, nature of the substances depends upon is the short range and long range order is occurrence of the crystalline solid. And when it is the cut, this is the cut into the equal pieces is produced. Equal pieces cut into the equal pieces produced is called that in the and symmetrically arrangement of the particles of the crystalline solid. Okay, you already know crystalline solid is first and it is the regular shape. It is the orderly arrangement of the particles. Then after that true solid. Why it is called that in the true solid? Because of the and symmetrical arrangement of the particle is called that in the true solid. Then after that this one is called that in the anaesthropic nature. Why is called that in the anaesthropic nature means is the different direction, different along the different arrangement of the particles is the different direction is occurrence is called that in the anaesthropic nature. That one is if you have observed that. Then after that this one is the sharp melting point and it is the fixed temperature. Yeah, why? Because in the fixed temperature, because orderly arrangement of the particle, particular one temperature is given and is easily and melt. Therefore, is called that in the sharp melting point and then after that fixed temperature is formation. Example is the crystalline solid is come and diamond and then after that quartz. Okay, then diamond and quartz and sodium chloride. And sodium chloride, crystalline solid is come diamond and quartz and sodium chloride. That one is come to that in the crystalline solid. Okay, and other elements is also is come to that in the gold. Therefore, that one is also crystalline solid is come. Then if you go to that in the amorphous solid, amorphous solid and short range order, you already know. And the first is go to that, sorry, and this is the disorderly arrangement of the particles, disorderly arrangement of the particles, disorderly arrangement of the particles. The crystalline solid is the notation, simply say in the notation, disorderly arrangement of the particles. Then after that, this is called the pseudo short range order, Why? Because it's the short range order, because it's the disorderly arrangement of the particles is therefore is considered in the short range order. And then after that, this is the pseudo solid or supercooled liquid. Pseudo solid is considered in the supercooled liquid. Why this one is the pseudo solid and supercooled liquid? Because it's the slowly move to the liquid. Slowly move to the liquid is called that, and the supercooled liquid and the pseudo solid. And this one, best example is the plastic. When it is due to the temperature and when it is due to the heat, slowly move to the liquid. That is called that in the pseudo solid, and supercooled liquid is called that amorphous solid. And short range order. And then after that, the variation of the temperature. Why it is the variation of the temperature? Because it's the disorderly arrangement of the particles. Therefore, in the variation of the temperature and ranging of the temperature, range of the temperature is considered in the and variation of the temperature. Because it's why disorderly arrangement. The particles is one group is there, disorderly arrangement, another one group is there, disorderly arrangement, another one group is and this is the different temperature, this is the different temperature, this is the different temperature. Therefore, it's the variation of the temperature. Crystalline solid is considered in the fixed temperature, amorphous solid is considered in the variation of the temperature, because it's the range, the temperature is increases, the range of the temperature, amorphous solid. This one, amorphous solid and short range order and pseudo solid and variation of the temperature, that one is called. Another one is called isotropic nature. Isotropic nature. Iso means what? Same. Iso means is what? Same. Okay. And if you are and same along the different direction. Same along the different direction. Where are you observe that is that same different and same direction is come, and the same direction. If your different direction is come to that in the same. For example, is the railway station. The group of people is there, and disorderly arrangement of the particles, disorderly of the peoples and populations in the railway station. That one is observed that in the IV point, and same is produced. Therefore, and same along the different direction. Best example is the railway stations. So many people is there, and different. If you observe that in the same occurrence, and same is the produced. And where are you observed that in the same is produced? Same along the different direction. Where are you observed that in the same along the different direction? Isotropic nature. The isotropic nature is example is called quantum glass, plastic and rubber. This rubber and quantum glass, plastic and rubber is considered in the amorphous solid. That's all. Crystalline solid and amorphous solid. Difference between, if you are asked that in the questions, and difference between crystalline solid and amorphous solid. And crystalline solid is considered in the short range as well as the long range order. Amorphous solid is come short range order. This one crystalline solid is the orderly arrangement, and amorphous solid is the disorderly arrangement. And this one and crystalline solid is considered in the true solid, and amorphous solid is pseudo solid and supercooled liquid. Okay, then it is the symmetrically, and when it is cut into the equal piece produced in the crystalline solid. Amorphous is when it is cut is the disorderly arrangement. This one anisotropic nature crystalline solid, and then amorphous solid is come isotropic nature. Crystalline solid is completed in the quartz and diamond, sodium chloride. Other elements is gold is come. This one amorphous solid is come plastic, rubber. That one plastic and rubber and quartz glass is come to that in the amorphous solid. And crystalline solid simply say shining. CET questions, you already know crystalline solid, and already you know about it, and short range order as well as in the long range order. The first is the crystalline solid is how it is formation in the short range order only, long range order only, both short range and long range order. Option and the question is 3. And why? Because it's the crystalline solid, you already know short range order as well as in the long range order is completed in the crystalline solid. Second question, which of the following is an amorphous solid? I say, and that one is come, amorphous solid is come, simply say about in the plastic. Plastic is called that in the, and rubber, that is called that in the amorphous solid. Teflon, that is also polymers. Cellophane and polymers, polyvinyl chloride, fiber clothes, all of this is considered in the amorphous solid. Amorphous solid is simply say about in that in the plastic and rubber and quartz glass. This is Teflon also, polymers is content is come cellophane and polyvinyl chloride and fiber glasses and all of this is considered in the amorphous solid. Is best example. Amorphous solid such as the glass may be is classified as, and it is the supercooled liquid, supercooled solid, superheated liquid and superheated solid. Which one is come? Questions is come. Option is considered in the supercooled liquid. You already know amorphous solid, and is the such as the glass may be is classified is considered in the supercooled liquid, and best example is what you call pseudo solid and also supercooled liquid. Why is the supercooled liquid? And the liquid is the slowly move to the liquid is called that in the supercooled liquid. Another one example is the window pans, and the ancient period of the window pans is the but upper level is come to that in the thinner and bottom layer is the thicker. Why? The slowly move to the liquid is go to that in the settle down the bottom layer, therefore come to that in the bottom layer is the thickness. That one therefore is come to that in the amorphous solid such as the glass maybe is the when it is melted, and this is the supercooled liquid. Why? Because it's the slowly move to the liquid. I hope to understood my concept of the solid and crystalline solid and amorphous solid. Please subscribe to my channel, and anyone doubts and please comment the